thank you for the nice introduction. My name is Lowke, and as it was called, I'm a professor for digital application technologies at the Technical University in Munich. And today I want to talk about additive manufacturing in construction and the challenge of large scale. The title of this presentation is exactly the title of our TRR 277, which is a G-funded collaborative research center. And saying that it is, I'm here, or I'm presenting today on behalf of the board of the TRR. As here is spokesperson Kocht and Katja, and of course I'm here to present on behalf of the researchers of the TRR 277, which you can see here from our last meeting in the summer at TRR. So since I'm kind of the speaker today, I'd like to put the whole topic into maybe a more general view, and I want to start with this graph here, which shows the population development in the world. And when I was born, it was somewhere in the middle of the 1970s. There were about 4 million people on this earth. And some months ago, you heard it from the news, we exceeded 8 million people. So there's a steep increase in population on the world.
You have audio from this corner
In
on the stream. I think the webcams are recording audio, and you should mute the webcams.
10.4 billion people on this world. This increase in population means that we have an increased need for construction. These people need housing, these people need infrastructure. In addition, we have an increase in prosperity in the developing countries and in China, and this again increases the demand of construction in the future. There's no doubt about that. On the other side, we know that we have a climate crisis, and to mitigate this crisis, we have to reduce emissions and resource consumption. And the great challenge for the construction industry in the next years or decades is to build more with less resources and less emissions. However, construction is not prepared for this challenge. As you can see here, since the 1970s of the last century, the productivity is almost constant. We have not developed in construction, we have the same productivity than in the 1970s. And on the other hand, with this technological, or with the stillstand in technological development, we are less attractive for young people. It's the second problem we have. Young people are not anymore keen to become a civil engineer, for instance. So if we have a look in other industries, we see there is huge progress in automation, but on the right side, in construction, we still have this huge amount of labor activities on the building side. And digitalization has not arrived at the construction process too far. Also, there were some progress in the planning phase. I think a lot of architects are here, but as you come to the building side, it's a break in the digital chain, and the real construction process is not digitally.
Is it working now?
Furthermore, if you look on the right side, you see typical construction elements made of concrete here, and these are often characterized by a mass-intensive and resource-consuming geometries, and this means we have a high CO2 emissions here. So the good news is, with additive manufacturing, promising construction technology is emerging right at the right time here. Then, because we believe that technology of additive manufacturing can help solving a lot of the problems I mentioned before. With additive manufacturing, for instance, you can significantly increase the automation in the construction industry. With additive manufacturing, you have no need for special tools if you want to produce different shapes or different forms. So we can produce shape and form optimized concrete elements, which results in reduction of resources we need for these elements. And there's research where you can see that the reduction of masses in concrete construction, for instance, could be up to 50%. Well, and this is precisely where the Collaborative Research Center, TR277, steps into. The TR277 is, as I told, a research on additive manufacturing in construction, and we have been investigating the additive manufacturing technology since 2020. So we are now in our 4th year. And the mission statement of the first funding period of this research program was the challenge of large scale. Because what distinguishes additive manufacturing in construction from other additive manufacturing technologies in other industries is exactly the large scale. There are a lot of challenges which result from the large scale, and that's why we need special solutions for additive manufacturing in construction. Let me shortly introduce the TR a bit more in detail. The research is structured in 3 focus areas. You see here in the middle, the focus area R is materials and processes. Then we have focus area B, computational modeling and process control, and focus area C. You don't see my mouse, so maybe I should do this. A good one. And we have focus area C, which is design and construction. In focus area R, we fundamentally investigate the interaction between the processes and the material properties. And focus area B, we then systematically enhance this research by numerical modeling. And in addition, we have a focus on controlling of the processes and the path planning. And in focus area C, we finally investigate the interfaces between the AMC processes on the one hand side and the prior design and the following construction site organization. In TRR, we intend to cover all additive manufacturing processes. As you can see here in the middle part, we have basically 2 main process technologies, the particle bed technologies and the deposition technologies. And we aim to cover all important materials for construction. So this means we are doing a lot of research on concrete. So this is the most used material in construction. Then we have research on earthen materials, of course steel and metal materials, fiber materials, and we have a project who's focusing on wood 3D printing. And let me show you some insights of our research. So here you can see some of the processes and the process material combination we do research on. This is the concrete printing process, Shotcrete 3D printing, and here you can see we think about how to integrate the reinforcement into these processes. Then we have concrete extrusion and clay extrusion processes. Mobile robotic is a big topic in our research. Then here you see particle bed technology, another interesting technology to produce really high resolution objects and objects with a high freedom of form. Another project is this Selective Cement Activation, and we go even higher in scale and we investigate the large particle printing. Then we dealing with new technologies like this injection 3D printing. We will see more here in this conference. And of course, earthen 3D printing, another important topic. Here you see an automated ramming process. Wood printing. Here we developed a structured timber process by individual layer manufacturing. And of course, steel as the second most used material in construction. So here we are looking both on the deposition techniques. Here you can see a wire and arc additive manufacturing technology, and on the powder bed techniques. As example, here you see a part from laser powder bed fusion. So that was a short first impression of our research. I don't want to go into detail here, but you have in total 10 projects in focus area R, which covering these process material combinations. So shortly, we have A1 and A2, which are focusing on particle bed techniques with concrete. We have A3, which investigates a near nozzle mixing extrusion process. Then we have this Shotcrete process we saw already in the video. Here we have a big focus on reinforcement integration. Then we have a separate project which is focusing specifically on how we could integrate reinforcement with fiber winding processes. Then, as I mentioned, the steel in A6 and A7, steel additive manufacturing, timber in A8, and then we have this new technology, injection fluid contact printing, and the earth additive manufacturing. Well, you see there's a lot of material projects combination. Then we have this research in focus area B and C, and the big challenge in such a research center is how to combine all these projects and how to bring the researchers to collaborate interdisciplinary. And here we developed an idea that we put a demonstrator in the center of our research, and all projects of the TRR can contribute to this demonstrator. As I told you, these demonstrators are large scale, so we are aiming to produce real building elements in the one-to-one scale, and all the projects of the TRR have to bring the expertise into these large-scale demonstrators. And now I will show you 3 examples of these demonstrators. In total, we have 9 large-scale demonstrators. If you're interested, then I invite you to have a look on our homepage. They can find all 9 demonstrators, but today I did a selection of 3 demonstrators. And let me start with our particle bed technology. You see it here in A01. This is the technology, the Selective Cement Activation technology developed in the TRR, where you bring a binder and aggregate in the particle bed. It's the dry particle packing, and then you activate by applying water on the distinct areas to harden the material. And this technology is characterized usually by really small building chambers, so it's not even close to construction scale. What we did is to increase this to the large scale, and fortunately here we have 2 industrial partners who built a large scale printer, and another partner who used this printer to build together with us this real scale element. And as an example, there was a design from the architectural department. We used this facade element, which you can see here. It's inspired by the architect Marcel Breuer, and you will see it later. It's a round-shaped building, and the function, or one of the functions of the element, is to have a natural shading depending on the location in the building. So each facade element has another geometry, and that's perfectly for additive manufacturing, because you can be really optimized in relation to the position of the facade element. Then we have further functions here. You see a microstructure on the surface, which is kind of micro shading, which helps to reduce the temperature on the building element. Then we have parts here in the middle of the element for thermal insulation, and at the back of the element we have the structural part of this facade element. And let me show you these videos that you become some impressions of the production process. This is the final element after production. So it's about 2.80 meters, I think, or even higher. Here you see the design is the building. These are the facade elements, and we picked one of the facade elements to produce it with selective cement activation technology. Here you can see the different functional areas. You have this structure, then you have this thermal area in the middle, and you have the structural function and the back of the element. here. Of course, we did some research on the material. I will not go into detail onto that. It's more about the production of the big element here. And here you see the 3D model, which are then got into a large-scale particle bed printer. It's 4 meter by 2 meter by 1 meter. So it's really able to produce this element in one part. And to increase the structural or the load-bearing capacity, we combined this printing process with mixed concrete. So we use part of the element as formwork to integrate the reinforcement in this case and to increase the structural load-bearing behavior. So this is the part in the back, or the inner part of the element. You can see the great advantage of these particle bed technologies is that you can really have high resolution surfaces, and you are really free in printing forms like hollow structures. Then we filled this structure with insulation material, and this is the final element. Okay. The second example is still in this lower area. It's printing with concrete, and we showed what we can do with the Shotcrete 3D printing process here in A04. And therefore, again, at the beginning there was a design process. It was this building here, you can see in the upper left. And we took out some special part of this facade again. And you see here this column and this wall element covered with a ceiling element. And on the right side, you see the process. It was printed in the digital building fabrication laboratory, again in a 1-to-1 scale. And again, you can have a look into the process with a video. So this demonstrator is called Shotcrete. And of course, we printed with integrated reinforcement here, because if we are talking about concrete 3D printing, then we always have to think about how to integrate the reinforcement. And we added a second layer, a vertical layer, to smoothen the surfaces. As in conventional technology, it starts with producing the concrete, of course, and then the 3D printing processes start. So the column and the wall element was produced at the same time. And here you can see how we integrated the horizontal reinforcement. It was done by hand here, but you can also imagine to have it with a pick-and-place process by the robot. And the vertical integration was done fully automated with this short rebar insertion technique. Here you have some impressions of the surface smoothing process. And at the end, the second layer or the cover layer is applied on the surfaces, and you can create a quite nice concrete surface. The second reinforcement process we used here was this fiber binding process. You can see here. So it's fiber wounded around the column and then covered with the cover layer to get the bond between the reinforcement and the concrete element. And this is the final product. So we ran out of time, so the ceiling was not ready at the time. We had to show this demonstrator, but we will produce in the next funding phase. Okay, the last process I will show you, this is a quite interesting process, and you can see, oh, by the way, this project A01, the facade element, the Breuer facade, will be presented later today, and also the project which I show you now, the injection 3D printing process, there will be a specific presentation here in this symposium later. So the injection 3D concrete printing process is a quite novel process. It's a process we developed at TU Braunschweig, and the idea here is that we inject material into a carrier fluid, and this carrier fluid is somehow holding the injected material into position. So the material is not sinking down or swimming up to the surface, is really hovering at exactly the position where we printed it. And the big advantage of this technology is that you can get rid of the layered structure of 3D printed elements, because you now can really print freely into the space wherever you want. So if we are honest, then the other techniques are more 2.5 3D printing, and here we have real 3D printing because we are going into space. And what you can produce with that technique is, for instance, these elements is really filigree elements, as you can see at this bridge example. And again, we will have some questions here in the video. So this is the design. The basement was produced by particle bed printing, and the bridge structure in the middle by these injections with concrete printing. Here you can see the path planning of the bridge elements. These bridge elements were segmented and produced in smaller parts. And here you can see the printing, the principle of the printing process in a gel, that you can see the concrete. But of course the gel is too expensive, so we developed a suspension made of limestone where we print in, which has the same properties, the same rheological properties than the gel, and we print into this muddy container here the bridge structure. At the end you have to remove the limestone suspension. It's not reacting in any way, so you can use it again for the next production process. It's only stone powder and water. Then you have to clean the object. Then we 3D scanned the bridge elements to 3D print again some connection elements between these segmented bridge elements. And then we assembled the bridge in a collaborative effort. So we needed a lot of researchers from the TR to bring it in form. And this is the final product. Okay, these were 3 impressions from our research. If you have further questions, please ask me now or in the coffee break. And last but not least, I want to use this opportunity to make you aware of a nice conference next year in Munich. So it's a digital concrete conference from the 4th to 6th September. And I all invite you to send abstracts. So the abstract submission deadline is soon, 22nd of November. But if you're a bit late, please write me an email. I'm sure we can manage to include it in the conference. So I hope I will all see you there next summer in Munich. Thank you very much.
Hello. Okay. Thanks so much, Dirk, for your great presentation. You presented a lot of very interesting topics and projects. Are there any questions from the audience? It's a great chance to ask in person. If not, I will start with just a question about, okay, you've presented how you've tackled some of the challenges through the TRR, and what do you think are the next challenges?
Of course, we are applying for a second funding period, and we choose a new motto for the second funding period, and it was the chance of a great impact. So what we mean with that is the impact on construction industry to really transform construction, and of course the chance on the ecological side to really reduce the environmental impact. So first, of course, by form optimization. I showed you this in this presentation, but a big topic in the second funding period is how to reduce the carbon footprint of each of the material we use for 3D printing. And here we are planning for going into the direction of net zero. And yeah, look how far we will come in the next 4 years.
Thanks. One question here.
the question about the material you use. So is it self-designed material, or do you work together with industry, and how do you keep the quality of the material at a certain level in these experiments and prototypes?
We use both. Of course, we have fundamental research. That's why we really have a deep look into the material. I didn't present anything about that topic, but we really go to the nano scale to improve the material. But especially or in particular for the architectural context, we use industrial material because printing this large element, you need a lot of material and you cannot produce it at university. So we have industrial partner for that, and we have material research for specific questions. Yeah, and quality control is the big topic. Here we are trying to go the way that we look or do research how we automatically control the quality by having inline quality control in the printing process. That's the vision we have, and we are working hard on it.